Hello guys, welcome to 100 Learning Together. This is Hashika, your physics and chemistry tutor. Hope you're all doing great. So hope you're all preparing well for your board exams. So here is an important video wherein we are going to discuss about the physics sample question paper. So we are all aware that the CBSE board has released the sample question paper. So in this short video, I'm going to explain the question with the answers for the sample question paper and we are going to analyze it. So from which chapter, how are the questions asked, from which topic should we concentrate more. So those kind of analysis we'll be doing in this video. So from this sample question paper, we know in physics, they ask questions for 25 marks. So the sample question paper that was released by the CBSE board has got two 1 marks in it and then one reason and assertion based question. So that is also 1 mark, one reason and assertion based question. So that also consists of 1 mark. And then they are asked about two 2 marks question. Okay, so 2 mark questions. 2 questions were asked. And then 3 mark questions. 3 questions were asked. 3 mark question. And then 1 5 mark question. 1 case based question. 1 5 mark and 1 case based question. So this is how the sample question paper has been framed. So basically you have got around 3 marks in 1 mark question and then 2 marks, 3 marks, 1 5 mark and 1 case based questions. So maximum questions have come from the important chapters and some important topics also. Like if you take light chapter, from ray diagram you have a question, based on problems you have a question, and then based on refractive index you have questions. So these are some important topics where you'll have to put in more effort and understand the concepts. CBSE board is mainly based on understanding. So unless you understand the concepts, it will be very difficult for you to answer the questions. So you will have to understand, practice previous year question, practice sample questions, then it is going to be very easy and you can easily crack your exams, okay? So we'll just get into the video and start with the sample question paper. So starting with the first question, it's a 1 mark question. So it's the 13th question. An object is placed in front of a convex mirror. So convex mirror. So herein you'll have to be clear with these concepts. A convex lens is very much similar to a concave mirror. And then we have got a concave lens, which is very much similar to a convex mirror. Okay, so this is how it is. So in concave lens and convex mirror, you have 2 ray diagrams, whereas in convex lens and concave mirror, you have got 6 ray diagrams. So all these 6 ray diagrams are important. You can compare and study, then the nature and then the image formation, all those will be very much easier. Just try to compare and study, it's going to be very much easier. Okay, an object is placed in front of a convex mirror. So here is an object and you have placed it in front of a convex mirror. Okay, and you also know a convex lens and concave mirror is converging, whereas a concave lens and convex mirror is diverging. So these mirror will diverge. The convex mirror will diverge the light rays. So now how is the image formed is the question. At a distance equal to the object distance in front of the mirror, this will generally happen when it is placed at the center of curvature or in a plane mirror. So that option is wrong. At twice the distance of the object in front of the mirror. So you're not getting the image in front of the mirror. So these two options are wrong. Half the distance in front of the mirror. So it is not formed in the front of the mirror at all. So all these 3 options are wrong. The image is formed behind the mirror for a convex mirror. So option D is right. Behind the mirror, and the position will vary. So wherever you place the object, accordingly you will get the image. But the image will be diminished, the image will be virtual and it will be formed behind the mirror. So these 3 are the nature for the convex mirror. Okay, so it's going to be diminished, it's going to be virtual and it's formed behind the mirror. For concave lens also it's going to be diminished and virtual. So remember these so that it will be easier for you. Okay, so moving on to the next question, the 14th question. A light is entering the atmosphere. So say sunlight, it is entering the atmosphere. So in the atmosphere, you have got fine particles. It's made up of atoms and molecules, dust particles. So it has got fine particles. So when the light enters into these particles, so there are chances for it to undergo refraction. So what is refraction? Change in the direction of light. So the light will get deflected in different directions. Okay, so it will deflect in all possible directions. So this is due to reflection, atmospheric refraction, scattering of light and dispersion. So this is due to scattering. So the light rays will move in all possible direction and it's due to the scattering, and this is Rayleigh scattering. Next one. A compass needle is placed near a current carrying wire. The deflection of the compass needle decreases when the magnitude of the current in the wire is increased. The assertion is false. So what will happen? The deflection in the compass needle will increase when the magnitude is increased. So when the current increases, the deflection will be more. Here they have told the deflection is less, so the assertion is false. The strength of the magnetic field at a point near the conductor increases on increasing current. Yes, when you increase the current, the strength increases. So the reason is correct. It's a correct statement, but whereas assertion is false. So this is easier. The trick is you'll have to understand the statement clearly and then you'll have to try the answer. Okay. Assertion and reasoning based question. If you ask questions like why, if you try to connect these two sentences with because, it will be very easy to find if it is right or wrong. Okay. So this is the answer. So this is about the 1 mark questions. Now moving on to the 2 marks. So I did mention refractive indices is an important concept. So based on this concept, the questions are being repeated in most of the board exams. Okay. So the refractive index of the 3 medium is given here. So it's 1.6, 1.8 and 1.5. A light is traveling from A to B and then from B to C. Okay. Imagine like a rectangular glass slab. So from A to B it's traveling, again from B to C it is coming outside. In which of these cases the refracted ray bends towards the normal? So here from A to B, the refractive index is increasing. If refractive index is more, the formula for refractive index is C by V. So if refractive index is more, it means the speed is decreasing. So if the speed is decreasing, we are entering into a denser medium. So we are entering a denser medium. So when we go into the denser medium, it will move towards the normal. Okay. So when you move from A to B, it's moving towards the normal. Whereas from B to C, the refractive index is decreasing. So the speed will increase. So we are entering into a rarer medium. Okay. So option A, for the question A, the answer is A to B. And then in which of the case the speed of the light will increase? So here you see when they move from B to C, the refractive index is reducing. So the speed will increase. So this is the answer. So here is the answer. When light ray from an optically rarer medium enters into a denser medium, it moves towards the normal. Since the refractive index of B is greater than A, the light ray will bend towards the normal on passing from A to B. And then in which medium the speed will be greater? The refractive index of C is less than B, which means the speed is greater in the second medium. Okay, so this is the answer. So with just the concept, you can answer in your own words. So this is the concept. Moving on to the next question. A piece of wire of resistance R is cut into 3 equal parts. These parts are then connected in parallel. So R1, R2, R3 is now connected in parallel. If the equivalent resistance of this parallel combination is R1, what is the value of the ratio R1 is to R? So we'll have to find the ratio between R1 and R. Okay, so first we'll solve this sum. So now R is being split into 3. So each resistance will be R by 3. So if it is parallel connection, we know the formula is 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So the value is just half of it. So here they have mentioned the equivalent resistance as R1. Okay. So it's R by 3. So you have substituted. So when I substitute instead of R1, R by 3, we are just reciprocating it. You are reciprocating it. So when we reciprocate, you'll get this term 3 by R, 3 by R, 3 by R. Since you have got the common denominator, you're just adding, it's 9 by 3. So R1 will be R by 9. We have to find the ratio between R1 and 9. So you can just cross multiply this. So you'll have R in the below. So R1 by R is 1:9. So this is the ratio. So it's a simple question. It's based on the resistance concept. You have a wire and you're splitting it into 3. So the resistance is R by 3. Okay. They are telling the equivalent resistance is equal to R1 and find the ratio between R1 and R. So it's a direct sum. Now the second part of the question is easier. Refer to the image and state how the magnetic field pattern region it indicates regions where the magnetic field is stronger outside the magnet. So where it is stronger, where the magnetic field lines are closer, it will be stronger. See here, the magnetic field lines are closer, so they are stronger. So compared to the center, the magnetic field lines in the near the poles are stronger. Okay. What happens to the magnetic field when the current in the circuit is reversed? When you reverse the current, the magnetic field will also get reversed. So that's the answer. The second one is comparatively easy to the first one. So the magnetic field strength is where the lines are crowded. So it is closer to the poles. Okay, so near the poles, it is stronger. And then the direction of the current when it is reversed, the magnetic field will also be reversed. You increase the current, the magnetic field will get strengthened. If you reverse it, magnetic field will also get reversed. Okay, then the next question. Now we are moving on to the 3-mark questions. Explain why the refractive index of a material with respect to air is always greater than 1. It's a very simple concept. Mu is equal to C by V. So speed of light in air or vacuum is 3 into 10 to the power of 8. So when you enter into any other medium, it's going to reduce its speed. Okay, so when light enters from one medium to another medium, the change in the speed. So in air or vacuum, you've got the maximum speed. So you're going to enter into some other medium like glass or water, your speed will get reduced. So here, obviously, V is going to be a smaller value. So when you divide a bigger value with a smaller value, your answer is going to be greater than 1. So this is the answer. So in the figure below, a light ray travels from air into a plastic block. Okay, so this is plastic block and outside you have got air. So outside the medium is air. So when it is entering, there is no deviation. The light ray does not deviate. When will the light ray not deviate? The light will not deviate when you pass it through the normal. So this ray acts as a normal. That is the reason it did not get deviated. Okay. And then complete the ray diagram. So now we'll have to complete the ray diagram. So from air, it has entered into plastic. And again from plastic, it is coming out to air. Okay. So from a denser medium to a rarer medium. So it will move away from the normal. So we'll see the answer. So the refractive index of the medium with respect to air is given as speed of light in air by speed of light in the medium. Since the speed of light in any medium is always less than the speed of light in air. The speed of light in any medium is always less than the speed of light in air. That is why it is greater. And then the light ray is undergoing normal incidence. So it's passing through the normal. That is the reason it's not getting deviated. So there is no deviation. Here it has moved away from the normal. So from a rarer medium, the light has entered into a denser medium through the normal. So no deviation. Then again from the denser, it is moving into the rarer. Here it will go away from the normal. So this is about the 3-mark question. So they have split it into 3 questions. This is an easy question. State the law that explains the heating effect. So Joule's law explains the heating effect. So what does Joule's law tell? The amount of heat. If your device is getting heated, the reason is you're charging it for a longer time or the current is passed through it for a longer time. And you're using it for a longer time. And then the resistance is more. So Joule's law of heating states that the heat dissipated across a resistor will be directly proportional to square of the current, the resistance of the conductor and the duration time. So H is equal to I squared RT is Joule's law of heating. And then the second question, list the factors on which the resistance of the conductor depends. So it depends on the length of the conductor, it depends on area, the nature of the material and the temperature. It depends on length, area, nature and temperature. They haven't mentioned how it depends, so you need not explain it. They have just asked us to list the factors, so we have listed the factors. So if they have asked us to explain, then we'll have to explain how it depends on it also. We should explain. Okay. So if they ask you how it depends, if length increases, resistance increases. If area increases, resistance decreases. Temperature increases, resistance increases. So this is how you explain it. And another 3-mark. Ananya responded to the question, why do electrical appliances with metallic bodies are connected to the mains through a 3-pin plug? If you take a refrigerator or an AC or if you take any laptop charger, all these will have 3-pin plug. But if you take a normal electric bulb, it will have a 2-pin plug. What is the reason? So she explained 3-pin connections will reduce the heating of the connecting wires. Is her answer correct? No. Her answer is not correct. Okay? Justify. So the 3-pin plug is usually done for protection. Okay? So the longer one, in a 3-pin plug, if you see, you have a longer pin and then 2 shorter pins. So the longer pin in the center, we call it as the earth pin. So this earth pin is for the protection. Okay? So it will, if there is excess current that is flowing, it will provide a low resistance path and it will pull all the excess current. Because when you touch a refrigerator, it is made up of a metallic case, right? So metal is a very good conductor. If there is a leakage of charge and if you touch the metal, we are also a conductor. So there are chances, high chances for us to get a shock. So to avoid that, to protect us from electric shocks, we have got this 3-pin plug. Okay. So it has got an earth wire which provides a low resistance conducting path to the flow of current if there is an accidental leakage, and to provide it from conducting in the metal and to protect us from the electric shock. And then, what is the function of a fuse? So it's also a safety device. If there is excess current, this fuse will melt and it will protect the other appliances from getting overloaded. So it is a safety device, okay, to provide the protection against overflow of current. It is a very important component because that will melt and will protect all the other appliances. So how it is working? It's a metal wire or strip that melts when the excess current flows through it. So this is about the 3-mark questions. Then moving on to the 5-mark question. So here you have got an image of a lens whose focal length is 5 meters. They are asking you the lens. So it's a convex lens. And a real inverted image is formed at a distance 7 meter. So F is 5 meter. So it's a convex lens. And then you're getting an image at a distance 7 meter. The question is you should find U. They're asking you where is the object. Okay, and draw a label diagram. So it's a simple question. So we know F is positive, V is also positive. We are using the lens formula. 1 by F is equal to 1 by V minus 1 by U. And we have found out the value of U to be minus 17.5. Okay, so now it's like the image is beyond C or beyond the F, the 2F, and you have got the object between, that is between F and 2F, you have got the image. So this is the object and this is the image. So you have to draw arrows. Don't forget to draw the arrows. Arrows are very, very important. Where these two light rays meet, you get the image. So the image here is diminished. They haven't asked the nature, but the image is diminished and real. Okay. So this is a direct sum. You can directly substitute. And you have to draw the ray diagram also. Then a 10 centimeter long pencil. So they have given the height 10 centimeter of the object. Is placed 5 centimeter in front of a concave mirror. So U is equal to minus 5 centimeter. Radius is given. So we can find the focal length. It will be 20 centimeter. Now find the position of the image. V is equal to question mark. Size of the image I or H dash is equal to question mark. Draw a ray diagram. So here again it's a direct formula substitution. We know the value of U. Then focal length is going to be half of the radius. So we know the value of focal length. We are going to find the value of V. So V is 6.67. So magnification formula is V by U. With the help of that, we can find out what is the magnification value and then find out the value of the size of the image. So it is 4 by 3. So this is how you get the image. You're placing an object and you're getting an image that is formed there. Okay. So they've asked us to draw the ray diagram. So make sure you draw the ray diagrams. Okay. So this is about the 5 mark. And finally, the case-based question. Vinita and Ahmad demonstrated a circuit that operates 2 headlights and 2 side lights of a car in their school exhibition. Based on their demonstrated circuit, answer the following question. State what happens when switch A is connected to position 2. So here when you connect, what will happen? These two will glow. If you are connecting it here, what will happen? These two will work. That is about the first question. Find the potential difference across each lamp when lit. So these are all parallel connections. So in parallel connection, the potential difference will not change. So it's going to be 12 volt. And then calculate the current. So you know the resistance value, you know the potential value. You can use Ohm's law, V is equal to IR, and find the value of current. So here's the answer. So first case only 12 ohm lamps will be on, second case only 4 ohm lamps will be on. Since it is parallel connection, the potential difference will not change, the current only will change. Now we are calculating the current with the help of the Ohm's law. V is equal to IR. So I is V by R. So here for 12 ohm, 12 divided by 12. For 4 ohm, it will be 4 divided by 12 divided by 4. So you're getting 1 ampere and 3 ampere. So less the resistance, more the current. This is about the first question. The second one, show with calculation which type of lamp has higher power. So usually power and resistance are inversely proportional. So P is equal to V squared by R. So if you want higher power, it should be low resistance. The answer is 4. With the help of theory, we can answer it. But here you're going to prove it with the help of the calculation. So this is the formula. So in both the cases, the potential will not change. So 12 into 12 by resistance is 4 and 12 you're substituting. So the one with 4 ohm will have the highest power. Okay, so this is about the case-based question. So if you see now, how is the question distributed? You have got questions based on ray diagram. You have got question based on the problems from lens and mirror. And then you have got question based on refractive index. And then we got questions from electricity. So electricity also equally important. You'll have to go through all the problems. And like, you know, the case-based question here is from electricity. So from light and electricity, we can expect the case-based question. So give importance. First highest weighted chapter is light. Then you have got electricity, then magnetic effect of electric current, and then comes human eye and its colorful world. So from human eye and its colorful world, myopia and hypermetropia is important. Applications are important. So based on that, you can definitely expect a question. So this is how the pattern is. Make sure you go through everything, all the problems. You have got problems only from 2 chapters. So make sure you solve all those problems, at least the basic methods, so it will be easier for you and you can feel confident. So if you ask me how is the sample question paper, I would say it is easy for physics because there's not like twisted questions. So compared to the previous year questions, here the questions are directly asked. So we can expect that the board also will be easier with respect to physics paper. So the questions are direct and it's going to be easier. So make sure you just prepare well. So just be ready with all the important concepts, solve all the problems. So solve all the previous year questions also. Okay. So we are here to help you. So all the best for your examination, whatever help you need. So if you need any important questions or previous year questions, whatever help you need, just make sure you comment it so that we'll be able to help you. Okay. So if you feel this video is useful, like the video, share it with your friends. So subscribe to our channel. So you can just comment, feel free to comment whatever is your query, whatever is your need. So you can just leave a comment and accordingly we'll help you with more videos and live sessions. Okay. So I'll meet you in another important video. So till then, bye bye, take care, all the best for your preparations.